students, in today's class we will study the application of Avogadro's law, vapor density and the percentage composition. In continuity, you will also study the empirical formula, their determination or numerical problems. Now, in the previous class we have studied about the mole concept. The relation of mole with gram atomic mass, gram molecular mass, molar volume, Avogadro's number and so on. Now we are going to use the importance of Avogadro's law, or we can also write here, that is application of Avogadro's law. Avogadro's law. That is, this law is used to explain the importance, or that is in determination of different other physical quantities. Like you see, the first point, the first application, that it explains Gay-Lussac's law. Gay-Lussac's law. First point. I will explain it later. Second, it determines atomicity of gases. Atomicity of gases. Third, it determines molecular mass of gases. Fourth, it establishes relationship. This is most important component from here. It establishes relationship between vapor density and molecular mass. So these are the four main applications of Avogadro's law. Now we will explain it one by one. Like you see, the first application is to explain Gay-Lussac's law. Like you see, suppose we have an example. Hydrogen reacts with chlorine to give 2HCl. According to Avogadro's law, now we know that 1 volume of hydrogen reacts with 1 volume of chlorine, then it gives 2 volume of hydrogen chloride gas. This is according to Gay-Lussac's law. Now, here we have to use, this is according to Gay-Lussac's law. And using the Avogadro's law, we have studied that at same conditions of temperature and pressure, equal volume of gases contain equal number of molecules. So, according to Avogadro's law, it says that if it has X molecule, then it will also be X molecule, and here it will be 2X molecule. So this is the simple application of Avogadro's law. Now next, second application states that it determines atomicity. It determines atomicity of gases. Now we know that atomicity is the number of atoms present in one molecule of an element is called atomicity. Now, it may be monoatomic, diatomic, triatomic, tetraatomic, octatomic. Like you see, monoatomic, metals in vapor state or inert gases, they have one atom. Diatomic, O2, N2, Cl2, H2 and so on. That is, in one molecule of the element, like H2, in one molecule there are two atoms. That is, number of atoms present in one molecule of an element is called atomicity. Now, triatomic similarly, ozone, O3, tetraatomic, P4, phosphorus, octaatomic, S8. So these are the different elemental forms in which there are several atoms in one molecule of the element. Now, according to Avogadro's law, again you see, if we write H2 plus Cl2 gives HC2HCl. Now, here we see that if according to Gay-Lussac's law, it is one volume, and then it is two volume. According to Avogadro's law, if here there is one molecule, then it will also be one molecule, and then it will be two molecule. Here, according to Avogadro's law. Now, if we'll take one molecule of HCl as a product, then two molecule corresponds to one molecule of it. So, one molecule will be for 1/2 molecule, and it is again 1/2 molecule. Now we see that one molecule of HCl, this one has one atom of hydrogen and one atom of chlorine, that comes from here. So you write here that half molecule of hydrogen has one atom. Half molecule of hydrogen gives one atom. So one molecule of hydrogen gives two atoms. Therefore, atomicity of hydrogen is 2, that is, it is H2. Similarly, here from this part also, one half molecule of chlorine will give one atom. So, atomicity of chlorine will also be 2, that is Cl2. So, we see that Avogadro's law explains, determines the atomicity of gas. Now, a student, the third application is to determine molecular mass. We can also relate it from this part. We can add the atomic masses to obtain molecular mass. Now, the third and the most important part of this topic is that it determines the relationship between vapor density and molecular mass. Third part, it determines relationship between vapor density and molecular mass. Now, the first word from here is vapor density. Vapor density is in short written as VD, is also known as a specific gravity of the gas. As the name suggests, it is used mainly for gas and vapor, because we have studied that is in reactions the volume of solid and liquids are taken to be 0. Now vapor density, actually it is the ratio of density of a gas or vapor to the density of hydrogen at same temperature and pressure. So first of all, write its definition. The ratio of density of gas or vapor to the density of hydrogen at same temperature and pressure is called vapor density. Since it is the ratio, so it will have no unit. Now next thing, as we know that what is density? Mass of unit volume. Mass per unit volume is called density. So the mass of unit volume of gas by mass of unit volume of hydrogen means there is the same volume taken. So there is another definition for it. The ratio between the mass of any volume of gas or vapor and the mass of same volume of hydrogen at same temperature and pressure. This is the definition for vapor density. Now we'll see here that how is the Avogadro's law applicable in this part. Now you see, according to the definition, vapor density is equals to mass of any volume of gas or vapor to the mass of same volume of hydrogen at same temperature and pressure. Now just use Avogadro's law here. It says that if the volume is equal, the number of molecule will also be equal. Means if there is 100 molecule, hydrogen will also have 100 molecule. If it has one molecule, then it will also have the one molecule. So now you write here mass of one molecule of gas or vapor to the mass of one molecule of hydrogen at same temperature and pressure. Now we know that if we take mass of one molecule of gas, we can write molecular mass of gas, molecular mass divided by, since we know that this is the unknown gas, so we write like directly, but here hydrogen gas is given. Now its atomicity is 2, so we can write here 2 into 1, that is the atomic mass of hydrogen is 1 and it is diatomic, so we can directly write like this. So what do you get here? We see that molecular mass is equals to 2 into vapor density. So this is the actual relationship. So we write here that molecular mass is equals to 2 into vapor density, or vapor density is half of molecular mass. So in any question, if you are given the vapor density, you can find out molecular mass, or if the molecular mass is given, then you can also find out the vapor density of the gas or vapor. So this is one of the important application of Avogadro's law. Now we will use this information in solving the several numerical problems. Now students, in continuity there is a percentage composition, but before starting with that topic, suppose we take one example mathematical problem. Like suppose a cylinder holds 85 gram of a gas. The same cylinder can hold 5 gram of hydrogen gas at same temperature and pressure. Now you see here students that since the cylinder is the same, so the volume of the two gases will be the same. So whenever in any question it is mass of certain volume of hydrogen is given, then the first step will be required to calculate vapor density. Now the part of the question was find molecular mass of gas. So first of all, go for the vapor density because there is hydrogen gas for comparison. So what will you do? Vapor density of gas is equals to mass of any volume of gas divided by mass of same volume of hydrogen at same temperature and pressure. It is 85 divided by 5, hence 17. So vapor density of the gas is 17, and as a result it is easier for us to find the molecular mass, and as it is 2 into Vd, hence 2 into 17, that is 34. So this type of question is asked frequently in board exams. This is also one of the example, or that is the problem from the board exams or board question papers. Clear student? So this was one of the example from vapor density. Now the next topic in continuity is percentage composition. Now student, there is no theoretical explanation for it. Just this is explained with the help of numerical example. In lower classes like 6 and 7 in mathematics, you have studied a proper chapter of percentage. Now how do we know about the percentage? Percent means every 100, means we have to know that what part of a quantity is present in its 100 part. Means out of total 100 part of any material, what percent, what part of any individual substance is present. Like you have studied about profit percent, loss percent, interest percent, all of these things are the same thing. And what is a simple formula for calculating percentage? It is part by total into 100. Part means the part or component which has to be calculated. Total means the basic quantity, basic amount. Like you see, suppose you calculate profit percent, then what do you write? Profit obtained is the part. The basic, yani cost price, CP, is the total on which profit is calculated. Similarly, we will find composition of chemical substance in the form of percentage. Like you see, suppose we have example, find percentage composition of water. In this type of question, atomic masses will be given to you, but every time I suggest you must learn the atomic masses of element along with their atomic number for the elements up to atomic number 20. It will be frequently used up. Now, what will you do? You have to find out percentage. Means percent of hydrogen, percent of oxygen. Formula is part by total into 100. Total. What is total here? The molecular mass. Total mass of this substance. So we write here first of all molecular mass. Here it is 1 into 2 plus 16. That is 2 plus 16, hence 18. Now go for direct calculation. There is no any theoretical explanation. So percentage of hydrogen. Percentage of hydrogen. Part, that is 2, by total into 100. Now you have 11.11%. Similarly, percentage of oxygen. Now, what is its part? 16 by 18 total into 100. Again, you will see here it is 88.89%. So, this is the method of calculating percentage composition. Now, take one more example. Now, suppose there is some complex compound, and then you have to find out its percentage composition. Like the question is, find percentage of oxygen. Second, percentage of water of crystallization. In CuSO4.5H2O. Means this type of question is given. Again proceed like the previous example. Means first of all you will find here atomic masses will be given 63.5. It may be also given as 64 or 63 simply for avoiding decimal parts. Sulfur 32, oxygen 16, hydrogen 1. So first of all go for molecular mass. Now calculate it. 63.5 plus 32 plus oxygen 16 into 4 plus, now here you have to be careful. Here dot does not mean here multiply. Dot is and, means CuSO4 and 5H2O. So we will add here 5 into 5 is for total H2O, means it will be written in bracket. Sometimes a student use 5 with hydrogen only and oxygen is written single. That will be incorrect. Now you will find it out totally. It will be 249.5. So we have calculated it. Now go for the part calculation. Percentage of oxygen. Again part by total. Part of oxygen. Now you see here, that is in this part the oxygen, 4 oxygen are here and 5 oxygen is here. So what is the total number of oxygen atoms? 9. Hence it is 9 into 16 divided by 249.5 into 100. Now we will calculate it. This is the method of calculation. Similarly, percentage of water of crystallization. Water of crystallization. Here you see part, that is this part, means here it is 16 plus 2 18 into 5, that is 90. That is water of crystallization is 90 upon 249.5 into 100. Again you will find its answer. So this is the topic, percentage composition. Now clear, student? So after that we will start empirical formula and its calculation.